Assalamualaikum and hello to all who are watching this video. So this will be the explanation for CHEMCARE module, Chemistry 2 SK025 for Chapter 10, Carboxylic acid and its derivatives. This is going to be for stage number 1 first. Okay, so we proceed with question number 1A. Arrange the following compounds in order of increasing boiling point, and then explain your answer. So first of all, you need to highlight what does the question wants the order to be with. Increasing boiling point ataupun semakin menaik takat didih. Alright, so you are given three different molecule. You are given butanoic acid which has COOH. You have hexane which is just normal alkane. And you have 1-pentanol which has OH. So in order of increasing boiling point, you have to know that you are arranging from lowest boiling point to the highest boiling point. So make sure you are not confusing this order lah. So the lowest boiling point to the highest boiling point. Okay, so the lowest boiling point is the one that has no OH at all. So that will be your hexane, followed by alcohol, which is 1-pentanol. And then lastly, carboxylic acid is the one with the highest boiling point. So butanoic acid. Okay, so that will be the order. So let's explain why is it we arrange like this. First of all, both butanoic acid and 1-pentanol, they both have higher boiling point because they can form hydrogen bond between them. Which is stronger than van der Waals forces that can only be formed between molecules of hexane. Okay, so both butanoic acid and pentanol can form hydrogen bond between them. Hydrogen bond is stronger than van der Waals forces that you can find in the molecule of hexane. So that's why we put hexane has the lowest boiling point. However, between pentanol and butanoic acid, why is it we put butanoic acid as the highest boiling point? Because butanoic acid forms, we call it as stable dimers through two hydrogen bonds. Okay, carboxylic acid, the type of hydrogen bond is stable dimers through two hydrogen bonds. So, which is stronger? Ataupun we can say which is strongest lah. Okay, so butanoic acid forms stable dimers through two hydrogen bonds, and this type of hydrogen bond is the strongest type. Okay, so in terms of mark, you give this. First, the arrangement, you get 1 mark. Second, explanation, comparing hydrogen bond with van der Waals forces. And then why is it hydrogen bond in carboxylic acid is the strongest? Because of the stable dimers. So that was for question A. Question B, arrange the following compounds in order of increasing solubility in water. Again, highlight what does the question want. Increasing solubility in water. So now we arrange from left to right, increasing solubility. And then, increasing means we want to arrange the lowest solubility to the left, to the highest solubility to the right. Okay, so Between here we have OH. Alcohol 1-butanol has OH. Pentane is just normal alkane. And propanoic acid you have COOH. So you need to know solubility in water. It will check whether or not you can form hydrogen bond with water or not. That's all solubility is, whether the molecule can form hydrogen bond with water. So first, alkane cannot form hydrogen bond with water at all, because hydrogen bond must be between either FOON atom, fluorine, oxygen or nitrogen atoms. So because pentane alkane doesn't have any of this FOON, so it cannot form hydrogen bond. Next, butanol has OH, so it can form hydrogen bond with water. And propanoic acid, it has 2 OH, COOH. So it can form the most number of hydrogen bond. Therefore, the solubility will be the highest in water. Okay, so let's explain one by one. First, we say that pentane is not soluble in water because pentane is non-polar. So when it is a non-polar molecule, therefore it cannot form hydrogen bonds with water. Okay, make sure you mention with water, because if solubility, it has to be hydrogen bond with water. If boiling point, it has to be hydrogen bond or intermolecular forces between its own molecules. So the word with water is very important. So pentane not soluble because it is non-polar, cannot form hydrogen bonds with water. So that was the first one about pentane. Next, 1-butanol is soluble in water because the OH group in the alcohol can form hydrogen bonds with water. Very simple. Because there is OH, it can form hydrogen bond with water. Okay, lastly, how about your COOH? So next, propanoic acid is more soluble. Okay, both carboxylic and alcohol are soluble, but carboxylic is more soluble in water than 1-butanol. Okay, the reason why? Because it can form more. The key word here is more quantity, hydrogen bonds with water. Who can form the more hydrogen bonds? The COOH functional group. So the keyword here is more hydrogen bonds with water. Okay, so that was for question 1B. Proceed with question 1C. You are given the structural formula for 2 carboxylic acids, N and M. Compare acidity for the above carboxylic acid and explain. So compare acidity, you can say who is the higher acidity or which one is the lower acidity. Okay, both are acceptable. So let's look at the structure. Both have COOH, so both are carboxylic acid. The only difference is both have Cl with different distance. Okay, distance to who? Distance to the COOH. Structure M, the Cl is further, 2 carbons apart, but structure N is only 1 carbon apart. Okay, so this one is closer, further distance, further Cl, and this one is closer Cl. So what is so special about Cl? Cl is what we call as EWG, electron withdrawing group. So if you have Cl closer, if the distance of the Cl is less to the COOH, then your acidity will be higher because EWG is good for acidity. Okay, so we want the Cl to be closer to the functional group COOH. Okay, so let's explain. Cl is what we call as electron withdrawing group. Okay, so because it is electron withdrawing group, the closer the Cl to the COOH, the greater the effect of electron withdrawing group. We call it as inductive effect. So the closer the Cl to the COOH, the greater the inductive effect of the electron withdrawing group. Therefore, the more stable is going to be the carboxylate ion. So the more stable the carboxylate ion, hence the higher acidity. Okay, so let's check. Cl is electron withdrawing group. So the closer the Cl to the COOH, the greater the inductive effect. The more stable the carboxylate ion, the higher the acidity. So as a summary, which one should have higher acidity? Structure N is more acidic ataupun has higher acidity. Okay, so N has higher acidity than M because it has its Cl closer to the COOH. Next, we proceed to question number 2. You are given this following reaction scheme. Draw the structures of A, B, C, and then give reagents for 1 to 5. Okay, so let's look at your reaction scheme. You are given the carboxylic acid in the center. So let's look at reaction to produce A. So reaction of carboxylic acid with PCl5. This is nucleophilic substitution. So who is going to be nucleophilic? Who is going to be substituted? The nucleophile, which is the OH. So your structure A is going to be CH3, C double bond O, Cl. Okay. Next we proceed to structure B. NH3 is also going to be this one is going to be neutralization between carboxylic acid and NH3. So structure B is going to be CH3, C double bond O, NH2. And your structure C, which is at the bottom here, when carboxylic acid react with another carboxylic acid, this is formation of anhydride. Carboxylate with carboxylate, you are going to form anhydride. So what's happened? The first carboxylic acid, you are going to remove the OH. So this one is lost. The second carboxylic acid, you are going to remove only the H. So this is going to be connected to O, C double bond O, CH3. So this is the structure of anhydride. Okay, so next, reagent 1 to 5. So let's look at reagent 1. From alcohol to become carboxylic acid, this is oxidation process. From alcohol to carboxylic acid, this is oxidation. So reagent 1, we use strong oxidation, KMnO4, H+, and heat. We need to use strong oxidation. We cannot use PCC because PCC cannot form carboxylic. PCC can only form aldehyde. Okay, so strong oxidation. That is for number 1. Number 2, if we want to go from carboxylic, go back to your alcohol, we need to undergo the opposite process, which is reduction. So the opposite of oxidation is reduction, and the reduction is number 1, lithium aluminium hydride, LiAlH4 in dry ether. And number 2, we are going to add H3O+. Okay, that is reduction. Next, number 3. This is reversible arrow. You can see here carboxylic becomes ester. So this reversible arrow is process of esterification. So to find what is the structure of carboxylic acid add with alcohol, we need to find the structure of carboxylic first. Where is your carboxylic? Carboxylic is here. So your ester is going to add with alcohol, which is like this. So your reagent for esterification is going to be alcohol, which is going to be OH, and then 3 carbons, CH2, CH2, CH3. But remember, esterification is alcohol with acid H+, and also with heat. Okay, so esterification, alcohol, H+, and heat. Okay, let's proceed to arrow number 4. This is from nitrile compound to become COOH. So nitrile compound to become COOH. This is very straightforward reaction. You only have to react with H3O+, or we call this as hydrolysis of nitrile compound. CN becomes COOH. Lastly, for arrow number 5, here from Br to become Cn, this is nucleophilic substitution. This is under chapter 7, haloalkane. So for nucleophilic substitution, we want to substitute the halogen Br to Cn. We are going to use KCN in any alcohol. So let's say I'm using ethanol, and this one also require heat. Okay, so each of these you get 1 mark. Let's proceed to question number 3. This one is question number 3. So Kevlar is produced from the condensation of 1,4-diaminobenzene and terephthalic acid. And you are also given the IUPAC name lah. So don't worry, you will be given the IUPAC name. So what you need to do is only write the equation for Kevlar. So the first structure is 1,4-diaminobenzene. And then you react with 1,4-benzene dicarboxylic acid. Okay, let's draw the structure first. Diaminobenzene, the parent is benzene, and then it has amino at carbon number 1, NH2, and another amino at carbon number 4, para location. Okay, next, plus 1,4-benzene dicarboxylic acid. Again, the parent is, you have benzene with COOH, both at carbon number 1 and at carbon number 4. Okay, so to write the equation, you need to write the arrow to the bottom. And then this, what happened is, you are going to remove water. So how do you remove water? First, from NH2 on the left and the right hand side, we can draw a little bit expanded like this. Why? So that you know it's going to remove your OH from carboxylic and H from your amino. And both process is going to happen left and right side. So this will be from the left, benzene and H. This one also going to be only NH. Then this NH connect with C double bond O, another benzene, and then C double bond O. So what happened to the one that is broken on the left and the right hand side? This one bond that is hanging lah, hanging bond. And this hanging bond is going to become your polymer chain. So because polymer means many monomers, so polymer you have to multiply n. N is the number of monomers. So at the front of each monomer, you also have to add n. And then with the side product, it's going to be H2O. Okay, but how many H2O? Because you are using two different monomers, H2O is going to be 2n minus 1 H2O, because you are using two different monomers. So when you are writing this equation, this bracket or this symbol putus-putus tu, you don't show lah. Okay, I'm only showing so that you know you are going to remove water molecule. But complete equation should be like this. Okay, so in terms of marks, for this complete equation, you get the mark for your before, 1 mark, and the marks for products after, also 1 mark. Okay, so that was for stage number 1, chapter 10, carboxylic acids.